Ever wondered why apples fall straight down and not in a zigzag pattern? The answer lies in quadratic equations. These mathematical expressions with their unique parabolic shapes are fundamental to understanding the nature of falling objects. They are used to calculate the trajectory of a falling apple, the path of a soaring baseball, or even the route of a spaceship leaving Earth. So the next time you see an apple falling from a tree, remember, it's all about quadratic equations. A quadratic equation is more than just a combination of numbers and alphabets. It's a mathematical tool with a standard form. Now let's take a closer look at this standard form, shall we? When we say standard form, we're referring to the format x2 plus bx plus c equals sign 0. Here, a, b, and c are coefficients, numbers that determine the equation's characteristics, and x is our variable. Let's break this down. A is the coefficient of x2, and it's pretty special. It influences the direction and width of the parabola, which is the U-shaped curve you get when you plot the quadratic equation on a graph. If a is positive, our parabola opens upwards, and if a is negative, it opens downwards. The absolute value of a also decides how wide or narrow the parabola is. Moving on to b, the coefficient of x. It plays a big part in determining the position and direction of the parabola. A change in b shifts the entire graph left or right. Lastly, c, the constant term. This is the y-intercept, the point where our parabola crosses the y-axis. A higher c value shifts the graph up, while a lower one shifts it down. In essence, these coefficients, a, b, and c, are the superheroes behind our quadratic equation. They shape and position the parabola, giving our equation its unique characteristics. So, a quadratic equation is a parabola's secret identity, and the coefficients a, b, and c are the superheroes that shape it. Quadratic equations might seem complex at first, but once you get the hang of it, they're as easy as pie. Let's take a moment to reflect on what we've learned. Quadratic equations aren't just abstract concepts. They have real-life applications. They help us calculate the trajectory of a football, predict the growth of a population, and even design roller coasters. The essence of a quadratic equation lies in its standard form, x2 plus bx plus c equals sign 0. Here, a, b, and c are coefficients that shape the curve of the graph. A influences the direction and width of the parabola, b shifts it left or right, and c moves it up or down. Understanding these elements and their interplay is the key to mastering quadratic equations. So, keep practicing and exploring. Remember, quadratic equations are not just part of your syllabus, they're part of the world around you. So, go on, embrace the quadratic equation, and you'll start seeing its magic everywhere.